In this video, we'll look at the trigonometric identities. So we've already encountered these identities from the unit circle perspective of the trigonometric functions. So it's worthwhile to go back and look at these again and see if we can prove them from the triangular acute angle perspective, just to make sure that they hold true. So we'll show a couple ways of approaching proofs for the trigonometric identities, but we'll begin with the definition of the trig functions, then we'll go through both the reciprocal and Pythagorean identities. So recall that the definition of the trigonometric functions for theta, an angle in standard position, and pxy, a point on the terminal side, if r equals the square root of x squared plus y squared is the distance from the origin to pxy, then sine theta equals y over r, cosine theta equals x over r, tangent theta equals y over x for x not equal to 0, cosecant theta equals r over y for y not equal to 0, secant theta equals r over x for x not equal to 0, and cotangent theta equals x over y for y not equal to 0. And remember, I've got these two figures for two angles theta that land us in different quadrants. And also remember that it doesn't really matter where pxy is so long as it's on the line created by r, the slope of r, and origin. So since cotangent theta equals x over y, we can write this equivalently as 1 over y over x. And this looks familiar, so we know that tangent theta equals y over x. So we can say that cotangent theta equals 1 over tangent theta. So this works, this checks out for the trigonometric identities of angles, as opposed to the trigonometric identities of real numbers t, which is what we looked at in the unit circle definition. Now, just to do one more, since we know that cosecant theta equals r over y, this equals 1 over y over r, and then since we know that sine theta equals y over r, we can say that cosecant theta equals 1 over sine theta. So all of the same reciprocal identities hold true for angles theta with these trigonometric functions. You could prove the other ones if you wanted to, so it's probably worth taking the time to do the mental exercise to show that these are true. But the reciprocal identities we define as cosecant theta equals 1 over sine theta, secant theta equals 1 over cosine theta, cotangent theta equals 1 over tangent theta, and then we have tangent theta equals sine over cosine, cotangent equals cosine over sine. So now recall the Pythagorean theorem, x squared plus y squared equals r squared. So this will be a kind of novel way of proving the first Pythagorean identity, which you all will remember from our exploration of the fundamental identities through the unit circle definition of the trigonometric functions. First, let's say that this implies x squared over r squared plus y squared over r squared equals 1. So we've just divided everything by r squared. So this means that x over r squared plus y over r squared equals 1. And those are just our trigonometric ratios. We know that cosine theta equals x over r, and sine theta equals y over r. So we can just say cosine theta squared plus sine theta squared equals 1. And remember that we can unambiguously write this as cosine squared theta plus sine squared theta equals 1. So that's a nice quick proof from the Pythagorean theorem of the first Pythagorean identity. Now remember too that if you wanted to derive any of the other Pythagorean identities, it's reasonably easy to do so if we just divide through our entire identity by either sine or cosine. So I'll do one so you can see that. Let's divide everything by cosine squared theta. So cosine squared theta over cosine squared theta, that's 1. Sine squared theta over cosine squared theta, that's sine theta over cosine theta squared, which would be tangent squared theta. Let me write out that step so it's completely clear. Sine theta over cosine theta squared equals 1 over cosine theta squared. Now sine theta over cosine theta is tangent theta, so that'll be tangent squared theta equals, and 1 over cosine theta is secant theta equals secant squared theta. And like I said, you could derive the last one just by doing the same process, but instead of dividing through by cosine squared theta, you divide through by sine squared theta. So we have the Pythagorean identities. Sine squared theta plus cosine squared theta equals 1. Tangent squared theta plus 1 equals secant squared theta. This was the one where we divided through divide by cosine squared theta. And then the last one, 1 plus cotangent squared theta equals cosecant squared theta. And this one you get by dividing through by sine squared theta.